Okay, length of an arc. Again, I want to remind everybody, I probably will end up printing these out because that's how I go. Up on Classroom, formulas you need to know for the Regents exam is up there. And there they are right there, 12, sorry, 15. Okay, formulas you need to know that are not on your reference sheet. And one of them is arc length. Okay, arc length. So let's review that formula right now because it probably will show up. We're 3 weeks away, everybody, 3 weeks away. Length of an arc, here you go, everybody. Length of an arc formula. We used a word when we did this, soar. Soar. S equals, we'll bring back this variable, theta, times r. This is length of an arc, soar. Let's review each piece right now. What's each variable mean? Ready? S is the arc length. That's the length of your arc I substitute in for S. All right, theta. Again, don't get nervous about that. That's a variable. And what that means, that is the central angle of the circle. Remember the angle that comes from the center. That's your central angle. But here is the biggest piece and most important piece to this formula. When you substitute in, it cannot be in degrees. It has to be in radians. Okay? So when you substitute in for theta, that has to be in radians. And we'll talk about, hey, if I hadn't given degrees, how do you convert? Because your calculator converts for you. So when we come up across a problem that gives us degrees, I'll review how to do it in radians. And then I think everybody should be good with R. Radius length. Okay, there's the radius length. So 1 out of 15 formulas we got to know, huh? SOAR. That's for length of an arc. All right, let's do number 1 now that we reviewed that formula. Go look at number 1. Radius of 10 with an arc with a length of 2 pi. What's angle B? Okay, what's angle B? Why am I choosing to use this formula? What do they give me? Arc length. That's why I'm choosing to use this formula in particular. They are giving me the arc length. So that is why I'm going to use SOAR. All right, I need you to substitute in for me now. Your turn. I'm done talking. Your turn. There's a couple things I need to substitute in. First thing is, where's this 2 pi going? Into my S equals theta R. Where am I substituting 2 pi in for? Make sure you read what it represents so I can plug it into the correct spot. Lauren, where am I plugging that into? S, arc length. It says it's the arc length, and S represents arc length. So I'm substituting that in for 2 pi. And where's that 10 getting substituted in for? Drew? R. And I'm solving for B, theta. All right, so theta times 10. How do you get the 10 out of there? How do we get the 10 out of there? Look at that 10. Nope, maybe another day, huh? Lily? Divide both sides by 10. Everyone good? Divide by 10, divide by 10. And your calculator leaves it in terms of pi for you, which is beautiful. And also remember, theta is always in radians. What is it asking me for? In radians. Perfect. So, sorry, it's not. What's your calculator giving? It's not giving you 2 pi over 10. It's giving you reduced. What's the calc giving you there? Shara? Pi over 5. Okay, pi over 5. Let me do this right now before I go on to any other problems. Let me change the scenario. What if it said in degrees? Leave your answer in degrees instead. And we know that it leaves it in radians. So how do I convert? Let me show you a review how to convert again. Go to your calculator. Check in the top left-hand corner, everybody in degree mode. Everybody in degree mode? Okay, so what we're going to do is let's review how to change a radian into degrees. So go to your calculation screen. I'll do that myself. Okay, pi over 5. But we need to tell the calculator that that's in radian. That's a radian, pi over 5. So here's where we go to attach radian. You go to your toolbox. Okay, go to your toolbox. Scroll down to where you see units and constants. Everyone see that in their toolbox? Everyone, I'm going slow here. Toolbox, units, and constants. What do you think we want now? If you totally, but at least you got to this point, where do you think I want to go now? Length and angle, right? Because we're talking about an angle, length and angle. And then which one do you think we want? Angle, yeah. And then everyone see radian. So attach RAD to it. Can everybody get there? We're all right? Okay, so it's going to say pi over 5 radians. So now the calculator knows, okay, they're giving me radians, and you hit enter. And I believe you can go up. Oh, mine's in radians. Your guys are giving it in degrees, right? Okay, because my calculator's in radians instead of degrees. So if your calculator's in degree mode, everybody have the degree measure there? All right, so that's how you convert. That's where you go to convert. Okay. That's where you go to convert. Questions on converting? Again, you're not going to see what my screen says because I'm in radian mode. As you can see, if you're in degree mode, it should put it in degrees for you. All right, perfect. You're going to do 2 on your own or in your groups here in a minute. So there's length of an arc. One of a good number of formulas you need to know on your own. Let's go to a second formula you're going to need. Let's go to 3. Second formula. Everyone see the shaded area? That's called a sector. That's called a sector, if you remember that from our area unit, called a sector. So in addition to length of an arc, we're also going to need area of a sector. Okay, we're also going to need this formula. Okay, here it is. Area equals, we take the measure of the arc, so however many degrees are in this arc, which is also, remember, a reminder, you may not know this, but you might know this. What's that angle called again? That's the what of the circle? Central. Remember, central and the measure of the arc, always equal, always equal. All right, so you may not have the measure, but you know the central, it's the same thing. Over 360. And any stud in here know what I have to multiply that by? I said stud, but I'll take you too, Simon. Yeah, pi r squared. Good work. Good work. Good work. Yep. All right, so there's area of a sector. All right, let's figure out number 3 now. Read through number 3, what I gave you. Where can I substitute it in for? And what we're going to solve for in that formula. Area of the sector. All right, let's start. First one I'm giving is 12 pi. Where's that 12 pi going here? Read what it represents in the problem, please. Read it. Read it, what it represents, and where do you want me to put it in the formula? Where's that 12 pi going to go in my formula? Jonathan, where's it going to go? Okay, what's it say? Read the problem again. What does the 12 pi belong to? Yeah, the area of the sector. So where should it go in my formula? Right? 12 pi. I don't want to put it in for the it doesn't say it's the measure of the arc. It says it's the area. 12 pi. There is another number up here, 6. Where should I put the 6? Shara? Radius. So I am solving for, take a look. I am solving for the measure of the arc. But no. It said solve for AOC. Anybody want to tell me something? Same thing. All right, AOC and the arc are the same thing. Times pi 6 squared. All right. Before I call on somebody, can we just get rid of the pi's? Pi's on both sides. They're going to get rid of each other eventually. So let's get rid of them and write what we have left. 12 equals x over 360 times 36. All right, algebra studs, it's on you now. A couple moves we can make now to get x by itself. What's your move to get x by itself? We could make a couple moves here. Lily, what's your move? Sure, that's fine with me. We could, and anybody else was going to multiply by 360, you could have done that too. All right, I'll go with Lily's, which is divide by 36. So was that 1/3 over here? Your calculator's probably giving you. The 36 is cancel. X over 360. All right, on you now. That's on you. All right, when you have it, what is the measure of that arc or the angle? Either one there, Jared? 120, and make sure when you know that's 120 degrees that you're giving it degrees. And if you look at the problem, it does not state how to leave your answer, degrees or radians, so we can leave it 120 degrees. All right, arc length, area of a sector, all good, reviewing those two. Two that you definitely need going in. Questions? All right, next topic today. Circle equations. It's a formula day, I told you that. So let's review what the circle equation is and how it's used. This is also on your formula sheet on Classroom. All right, here it is, circle equation. X minus h all squared plus y minus k all squared equals r squared. There's my circle equation. That's what you need it to look like. Okay, let's talk about the two pieces of this circle equation. You take what the number in for h and you take the number for k. You put them together so they form an xy coordinate. So a number for h, a number for k, put them together, and that'll represent what of the circle? Remember that one? Center, yep, that's the center of the circle. Put those two numbers together, and that'll give you the center. And the second piece you get is, there'll be a number here for r squared, but that's r squared. You're worried about what r is by itself, not r squared, what r is, because that'll give you the radius length. So that's why we need the circle equation to look like that. All right, let's go to work here on number 5. Unfortunately, doesn't look like a circle equation. We need to convert it. Be prepared. You're going to have to convert it in 3 weeks. Going to have to convert it. Anybody remember that process? What that's called? You did it in algebra last year too. Yep, completing the square. Okay, so to get this to look like our circle equation, you are going to have to complete the square. Oh boy. All right, anybody remember first step? Complete the square, digging deep.
One side of the equation is zero.
No, that's the factor. Get one side. I actually don't want a side equal to 0. I want it equal to the single number. All right, so first thing we're going to do, take your x's, put them together, y's, put them together on one side, and get that single number over the other side, the number without a variable. So the first thing we need to do is organize this beast. So x squared, I'm going to put with, what's with x here? Minus 2x. So x squared minus 2x gets paired together. The y squared, which is what, plus y squared, plus 6y gets paired together. And remember I said I need that single number over the other side. So I have to move 3 over to the other side, and it becomes -3. So there's your first job. Group your x's and your y's together. Second job, find those magic numbers now that you're going to add to both your x's and your y's. Remember, we did x squared minus 2x. All right, I need this magic number I'm going to add to complete the square, and I got to do it for the y's as well. It's something I add on. I think you guys know. There will be some people who remember this. How do you find that number? There's a little process. Anybody remember how to find that number? Go ahead, Alexi. What do you think?
You divide the x and then multiply by 2.
Close. You had the divide part right. It was the afterwards. You divide by 2 and square it. Yes. So you take the b, what we call the b value. There's an a and there's a b. So -2. You cut it in half and square it. And it should always be positive because anytime you square any number, it's positive. So everyone right now, -2 divided by 2 squared. What number do we end up with? Finley? +1 goes there now. +1. Now do it for the y's. Do it for your b value, which is 6. Take that number, divide by 2, and square. Lily? 9. Good work. I said I'd only do it once when I taught you that. I guess I lied. I'll do it twice. What just happened here? Alexi, what happened here?
You have to add it.
It's unbalanced now. By adding 1 and 9 to the left, you made it unbalanced. So I got to add 1 and 9 to the right to keep it balanced. All right, we're almost there. Now it is time to factor. But not that bad. All right, let's take all the x's now. 2 numbers that multiply to 1 but add to -2. Let me repeat that in case you didn't hear it. 2 numbers that multiply to 1 and add to -2. 2 numbers that multiply to 1 but add to -2. Got some numbers for me, Shara? 2 numbers that multiply to 1 and add to -2. And? Okay, -1 and -1, right? So instead of writing x minus 1 and x minus 1, we can make it look like the circle equation, and we'll write what instead? X minus 1 all. Yeah, there we go. It's got to be the same number. -1, -1. Next one. 2 numbers multiply to 9, add to 6. It's got to be the same numbers when you complete the square here. 2 numbers that multiply to 9 and add to 6. Lauren? 3 and 3. Y plus 3 squared. I know that's giving you the shakes. I asked you to factor. You can always just take half your, look, you can always take half your b value too to get those numbers, right? -1, half of it, 3. So you can always do it that way if you get the shakes and get a little nervous by factoring. And then what's over here? 7. There it is. So we did answer the question. What is it? Choice 2? -1 plus 3, choice 2. Yep, but I have a bonus question, though, for a couple people. Bonus question. What's the center and radius, then? What's the center of this circle, and what's the radius length? So we'll start with the center. I know it's not asked, but it's a common question. Now that we did all this hard work, what's the center of that circle? H and K. Think about it. What must have been plugged in for H and K for me to get -1 and +3? Remember, it's x minus h squared, y minus k squared. So what must I have plugged in for h and k to get those numbers? Woo. Jared, what's good back there?
-1, 3.
-1 and 3. All right, here's my question, though. See how it's x minus h? I have x minus, those all match, so what's my h got to be? Just 1. And now go over here. -3. Yep. So I'm just taking the opposites out. And then how about radius length here, kids? It's not 7. Because remember, that's what? That is r squared. We're looking for r. Don't give me a big decimal either, please. Just give me a square root. That's fine. I'll take that. Jared, here you go. That's it. Yep, good deal back there. All right, perfect. Completing the square. We had so much fun doing that. We're going to do number 6 now. What's the center and the radius? Are you kidding me? He's going to make me do this again? No, I'm not, actually. I'm not. And I probably could have told you this during the circle unit, but that's not how we roll in an above average math class. Do you remember on Monday when we did equations of lines? I showed you on your calculator can give you the slope and y-intercept, can it? You know what else it can do? Give you the center and radius of a circle without doing all the work we just did here. All right, so here's how we do it. Same way we did it for slope and y-intercept. Go to your grapher. Go to grapher. Type in the equation I'm giving you of the circle. So go ahead, go to grapher. Type in that equation. X squared plus y squared plus 6y equals 7. And it'll tell you it's a circle, which is nice. Thanks for the info. Remember where you went for y-intercept and slope? Because that's the same place you're going now. Highlight it, go over your 3 dots. Go over the 3 dots, and where'd we go here? Details. Yeah, look at that, kids. Radius. Not only does it give you, it breaks it down for you, it gives you the x coordinate of the center and the y coordinate. Sorry, not sorry. I never told you that before. So what is that, choice 2? But hey, yeah, that's beautiful. If that's a multiple choice, listen, if that's beautiful, if it's a multiple choice question. Oh, ding, 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 I just go right in my calculator. I put that question on part 2 of the Regents exam, no multiple choice. You got to show your work. If you just write down what's in the calculator, we can only give you 1 point out of how many points it's worth. So keep that in mind. This is only good for multiple choice questions. If this is in part 2 or 3, you got to show your work by completing the square. All right, this doesn't mean, oh, forget completing the square now. No, you guys still do that on part 2 and 3. We good? All right, only good for multiple choice. All right, I'm almost done. Circle equations, last thing I got to talk about, which is our last thing we talked about this year, which was volume and density. I'm not going to go over any of these problems with you because we just finished the unit. I would just like you to make a note to remind yourself as you study for the test. I know they're going to do this to you, and I know some of you are going to fall into the trap. Make sure all the units match. All right? Make sure all the units match. Because what the Regents, and you'll see it as you practice, what they love to do is they'll give you a diagram. They will give you 3 dimensions of the diagram. 2 will be the same, 1 will be different, and you won't even notice. You're just going to go, oh, ding, 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 this times this times this, I'm good. Make sure all the units match before you start. Okay, before we go, can you go to number 11 for me, please? Number 11, there's a conversion I need to give you before you do that problem. That's not on your formula sheet, and that conversion is 1 meter equals 100 centimeters, so make sure you have that conversion. There are only 3 problems I want you to do on your own or in your group right now, and that is numbers 2, 4, and 11. Okay, 2, 4, and 11. So you're going to leave number 7 blank. 2, 4, and 11, I'll have the answer key up here. Once you get them correct and you're good, you move on to your practice Regents exams for the day. If you can't get them, you call me over or talk with somebody in your group. 2, 4, and 11, and here is the answer key up here. Okay. I put number 7 in there. That's not your responsibility, but 2, 4, and 11. Okay, 2, 4, and 11. Let me know if you have questions if you can't get anything.